Hello, this is Sean Mullery from Electronic Engineering at IT Sligo, and what I'm going to do in this short exercise is we're going to take a look at the prescalers, which are a system that the PIC microcontroller allows us to give us a certain amount of flexibility with regards to the timers that we're using. So here's the register that the information is in, so I'll just check the page number there. It's on page number 18 of the 16F 88 microcontroller. Now we're dealing with timer 0 in this case, so we've all the different parts to it that we're going to do. We're going to set it up as a timer, we're going to set it up as well, we don't need to set it up as edge triggered in our particular case because we're going to set it up as a timer, but here's the information that we're most interested in, which is this stuff down here. We never really looked at it before in any of the exercises that we did. So the first thing is here is the Prescaler Assignment bit. Now, if we want the Prescaler to be assigned to the timer 0 module as opposed to that thing that you see there called the WDT, that means the watchdog timer. It's not something that we've covered as of yet. If we want it to be assigned to the timer 0 module, then we must set PSA to 0, and of course I've done my usual thing, set to 0, which I shouldn't say. I should say reset or cleared to 0. So we need to clear that to 0. It won't automatically be that value to start off with, so you need to make sure that you do that explicitly, so write it in your code. Now that means that it will not be attached to the watchdog timer. It will in fact be attached to the timer 0 module. Now what that means is that if you look at the prescaler rates that we have here, TMR 0, if all I do is I set I clear PSA, in other words put it to a value of 0, if that's all I do, I will still have, or I will have my base rate of 000 here, which would be the still be a doubling of the amount of time that it actually uses. Okay, so the point here is that if we simply clear this bit PSA, it will actually change the way the timer works. Otherwise, so if we don't want the prescalers affecting our timer, that should be set to 1 so that it's set for the watchdog timer instead. And that seems to be the default setting for it, because we never set this before and our timers seem to work properly. So therefore this seems to be the default case that it would actually be set to 1. So we're going to clear that to 0, and then we're going to set these individual bits here, and we call these PS0, PS1 and PS2 for each of the different bits that we're dealing with. So the least significant bit is PS0, the middle bit is PS1, and the most significant bit is PS2. And we can see here that if they're all cleared to a value of 0, we will get a doubling of the timer. Now what that means is that if we set the timer to run for 100 instruction cycles, because this is set up the way it is, it will run for 200 instruction cycles. If we wanted to run for 400 instruction cycles instead, in that case, we would set PS0 to a value of 1, but we would clear the other two. And it's important that you actually explicitly clear the other two. They don't seem to be default to 0, or at least I haven't found in my particular system, but you can play around with your own one and see what the default is. But I think it's better to be explicit and to state exactly which ones that you want. So what we're going to do is we're going to take that information there. So you should write down in your notepad firstly capital PSA there, as we can see for the prescaler assignment. We're going to clear that to a value of 0. So we're going to say PSA is assigned 0. We're going to look at these numbers here and we're going to pick one of these. I'm going to decide that I want a 4 times multiplier here, so that's 001. And remember, you're going to have to set PS0 to 1, but PS1 is going to have to be set to 0, or say cleared to 0, and PS2 is going to have to be cleared to 0. Okay, so we'll move into our program here. Now, in order for you to save yourself a little bit of time, what you can do is you can go back, if you have your previous program where you did the toggling of RB0, it was one of the timer programs that we did earlier in the course. If you have that, then what you can do is you can use that to as a starting point for this program. So I'm just going to show you where we are in the user program here. You can see that I've set up trisb to be all outputs. I've used T0CS. I've cleared that to 0 to tell it that I want it to be a timer. I've set up my timer 0 interrupt enable by setting that to a value 1, and I've also set up the global interrupt enable bit to a value of 1. In my interrupt here, we can see that I'm checking for the timer 0 interrupt flag. I clear that interrupt flag, and then I set up my new value in the timer that I want to deal with. In the original initialization in user.c, I didn't set an initial time, so it'll probably start at 0. It'll run for the full length of it, and it's only when it first overflows that this starts to run at its correct timing. So I've set that up. I've said 255 is the largest number that we can put into an 8-bit timer. I've subtracted 100 from that, so it's at 155. And it's going to count up 100 instruction cycles. Now, just remember that we don't expect to see this toggle every 100 instruction cycles exactly, because it takes a certain amount of time after the overflow occurs to actually run the interrupt service routine. And we've seen in the past that can take anything between about 10 and 20 instruction cycles. So that puts us out by a fair bit. The good news is that when we change it using the Prescaler, so we're going to change it that we put in a value of 100 here, but we're going to set up the Prescaler to run it 4 times that. That will be 400 instruction cycles before it does its toggle, but we'll still only be adding on that 10 to 20 instruction cycles for the interrupt service routine. So the larger the value that you're using with the Prescaler, in other words, the larger the time that you're actually doing, then the less significant the overhead of the interrupt actually becomes. Okay. Finally, just in the interrupt service routine again, just to remind you, this is a previous program, but what we're doing is we're taking the previous value of RB0, we're complementing it. In other words, if it was a 1, we make it a 0. If it was a 0, we make it a 1, and that just toggles the port pin. So we'll just I think I already had this one running here, and you can see the instruction cycles as they're going there. I'm just going to take that down. So we can see the instruction cycles, the pulse that's coming out on the port pin here. Okay, and we can zoom in on it a little bit, and we can see it's happening approximately every 100 instructions at the moment. So we go from just before 600 to just before 700, and then we're just after 800. Now, what we'll find there is that therefore between there and there is slightly more than 100 instruction cycles, and between here and here is slightly more than 100 instruction cycles as well. As I said, you're adding on that extra 10 to 20 instruction cycles every time, because of your interrupt service routine takes a certain amount of time before it can run and actually change the setting. And as you've seen before, you could actually modify this to something like 80 if you wanted to get it a little bit closer to the amount. Now, what we're going to do is we're going to stop that program running there, and I'm going to go into user here, and I'm going to set up my Prescaler. So if we remember, we set up PSA, we are going to clear that. Okay, put it to a value 0. I'll just put in a little comment here to say that that is assigning the Prescaler to timer 0. Okay. What I'm also going to do now is I'm going to set up my Prescaler for a 4 times multiplier. So that's going to be a PS0 is assigned 1. So we're going to set in that. And I'm going to explicitly set to 0 the other ones, or clear to 0, sorry. PS2. And so I'll just write here as a 001 4 times, or 4 to 1. I'm just going to check, do they call that a 4 to 1 or a 1 to 4? It's a 1 to 4 they call it, so 1 to 4. And basically what the Prescaler does is it counts the instruction cycles, but it only updates the the timer every 4 of those instruction cycles. So it's as if it slowed it down by 4. And we'll run that again. And we'll just take a look at the logic analyzer here. So we'll just pause that there. And so if we zoom in on this, just see the effect it has. So we should be seeing a situation where it's toggling approximately every 400 instruction cycles. So if we take this point, we can see here that it's gone to a value of 0, just slightly below the 400 point here, and it's gone back up to a value of 1 just at the 800. Now what that suggests to us there is that we have the slight overhead here. We start at about, we can actually see the numbers there, this sometimes works and sometimes doesn't, 378 there, and there we are there at that. So about 370, 378, 376, something like that. And of course, as you can see here, it's gone up just slightly before the 800. So that suggests we've got about 20 instruction cycles of an overhead there on our 400 instruction cycles altogether. So as you can see, it doesn't affect each of the, if we multiply up the 100 that we put in our timer routine, just to show you that again in the interrupts here. If we put 100 in there, the Prescaler, as we've set it for the moment, has multiplied that to 400. But thankfully, the extra 20 cycles or so that the interrupt puts on it is not multiplied upward. That only happens once, because the interrupt only occurs when it overflows, and this 100 will have to wait for 400 instruction cycles before it overflows, because it only counts or so on every 4 instruction cycles. Okay, so what that allows us to do then is that within the settings of the Prescaler here, we have quite a bit of flexibility with regards to, you know, if counting from 0 to 255 instruction cycles is too little for us, we want a little bit more than that, but we don't want to be using a full 16-bit counter, then it gives us a little bit of flexibility to try different amounts, admittedly with larger increments. The same, the 16-bit timers, which can count up to a maximum of 65,535, which, if you're running at an instruction cycle pace of 1 microsecond, that would give you just over 65 milliseconds, which may not be enough for something that you want to do. So that this gives you the capacity again to up that a little bit in certain increments. And that can just give you that extra flexibility to be able to do your program exactly as you want it to do. Okay.